Okay, we're going to talk about vocabularies and linked data in this presentation. I just want to make a little note about this presentation that all the information in this is a topic that you talk about in IST 602 and 603. 602 knowledge organization. I'm pretty certain that you typically would talk about linked data. You'd obviously talk about vocabularies and a lot more. It's very much the theory of information organization. And in 603, I assume you're going to get a little bit of access to linked data in there, but definitely you're going to be talking about vocabularies until you're blue in the face. You're going to learn all about that. So this lecture is really about what vocabularies and linked data are in the realm of digital libraries. And some of this is stuff you really need to know, and some of this to do your job in a digital library. And this is some of the other stuff, especially with linked data, is information, new techniques that are sort of coming down the pike in terms of what the future of digital libraries and linked data is. So benefits of subject headings or vocabularies, we use those interchangeably. Some of these are pretty obvious, but it goes without saying that subject headings improve resource discovery, whether it's in your normal print-based library using an OPAC or in a digital library in our case. It allows you to do meaningful searches on your holdings in your digital library. You can retrieve by all sorts of facets. For example, you could do by object type. It could be, I want all the audio in the digital library. That could be your search, moving images, documents. Or you could do it by the actual digital format. So give me all the .wav or .mp3 or .tiff, so on and so forth. And then you can go by actual intellectual subject headings. So places, you can say I want all the contents in the digital library related to Albany County, or Columbia County, so on and so forth, or by person. So you get the idea how you can retrieve really by facets rather than just keyword searching. Consistent terms are used in names and subjects, so that can be used as an in-house subject to heading term list or by a controlled, authorized, or a subject authority. And we're going to talk more about that. There are many authorities, so you have to pick one and use it. You can use multiple ones or just use one. And we kind of use ontology and authority interchangeably. I'll probably use authority mostly for this presentation. There's a lot of, it's funny when you talk about some of this stuff, some of it's on a spectrum of term lists, subject headings, authorities, ontologies. So we'll just go with authority. A controlled authority control or controlled vocabularies organizes bibliographic information, and they dictate what you can put in a metadata field. Uses one distinct spelling. It took me a little while when you think of authority. The word, for some reason, I know what the word means, but when I heard it when I first went to library school, it always kind of sort of took me off guard for some reason. But basically it's the authorized use of that term, and typically there's a definition of how you would use it or what they mean. So think authority or authorized. So it's one source, Library of Congress subject heading, that's an authority. It's one authority that when you say I'm going to use this name or place or activity or whatever it is you're looking up, you can say, oh, that's the authority we use. So we use the Library of Congress subject heading authority. So again, names of people, places, things, concepts can be authorized. Facilitates browsing. Subject and name authorities were the only option for searching before the rise of computer search indexes. So search indexes and keyword searching is a relatively recent thing. Maybe not to you all, but in sort of the history of library science, it's a relatively new thing, especially pre-computer, pre-OPACs. Subject and name authorities were really the only thing you had in terms of doing knowledge exploration. Unless you knew you wanted a book on a fiction book on whaling, and you knew that it was written by Herman Melville, and the book was called Moby Dick, either the title of the book or the author, subject heading card indexes were the only way you could really look that up. You couldn't just search in Google, for example, books about whaling. That didn't exist. So that's why one of the reasons why controlled vocabularies, authority control is so important. Again, using subject headings, controlled vocabularies, decades-long history of doing it, techniques on how to do it, rules and theories. It's a tried and true method for organizing information. So we have three sort of basic kind of knowledge organization concepts, if you will, or practices. We have metadata standards. Metadata standards would be like MARC. We've talked about MARC a little bit. MARC is going out of fashion, but it's still around. It's sort of the original metadata standard. We have Dublin Core. We have EAD. We have hundreds, if not thousands, of metadata standards. These are just a few we've talked about. We have content standards. That's kind of a newer thing, although they've been around for a while. Again, all these things are relative how old or new they are, but DAX would be one that's used with EAD. That would be an archival content standard. RDA, Resource Description Authority, I don't know that one. That's a library one. That's a content standard. AACR2, which is a little bit older, American Anglo cataloging rules. Controlled format, this would be how in a metadata standard how that information is entered. So the best example of this would be like a date standard. You might say, oh well, the date goes in there, but how do you enter it? Well, there's ISO standards on how to do that, and one example would be where you do the year, month, day. And then what we're going to talk about is controlled vocabularies. Many of them out there, Library of Congress subject headings. The SCOS, which I don't know what that acronym stands for. I assume it's an acronym, but this is one I see heavily used with linked data, which we're going to talk about in the second part of the presentation. So different kinds of metadata standards, vocabulary, content, they all sort of come together to make a marriage, but you need to know a little bit about all of them and know one. You can't really live by one alone. Typically, if you're doing a digital library that's beyond, say, a little sandbox digital library or some little small project, typically you're going to have to use one or two of these in order to make it so your digital library can scale and it's sustainable over time. Some of the things that subject headings or an authorized authority control will do, without control there's no consistency. What happens is you start creating unique entries. So for example, over here we have uncontrolled or inconsistent values. We have a type of resource. So we have books, digital images. These are all these different types of resources, and we need to find out what's the authorized one we use. Well, depending on what we're using, it might be Dublin Core, for example. They might say for Dublin Core, for image, you use just image. For Dublin Core, on the other hand, and I don't know this offhand, I should, it might say still image is the authorized type of resource that you use. So it really helps you disambiguate which authority you're going to use, and it says this is the authority. If you're going to use Dublin Core or Library of Congress or SCOS or whatever you're going to use, you're going to pick one, and it's going to dictate to you how what the name is for that thing that you're looking up. Computers are very literal, so I might see, for example, again, if someone used image and they spelled image with a lowercase I, and then somewhere else they had it with an uppercase I, image with a period at the end. As a human, I'm going to know what they mean, but computers don't work that way. You can give them some, artificial reasoning. You can get them so they will accept uppercase, lowercase, so on and so forth, but that's not how developers and people in the digital libraries world like to operate. They like to see a consistent data entry and where you're using an authority, and then computer programs can be written much more efficiently. If you were to use uncontrolled values, again, not using an authority, for example, for your metadata work, it really makes it tough to sustain over the long period of time. When you go to do migrations from, say, one metadata standard to another, you're going to have to map all these inconsistent entries you've used. Say you've used image with a period, or you've used these sort of indiscriminately. Maybe you've even misspelled image and you use two E's or whatever. Those all have to be dealt with at one point or another. So the idea is when you're building your digital library, you deal with those problems right up front. Another thing that an authority will do will show you all the variances. You're talking about one person, but what are all the instances of that person's name, for example? So we have Elizabeth Taylor. She could be called Elizabeth Burton, Warner, Fortinsky, or the preferred term would be Elizabeth Taylor. Again, for this playwright, I don't know who he is, but a Spanish writer, there's going to be a preferred term for that, so that every time you describe a resource of this playwright or you show some relationship, you're always using the preferred term or the authorized term. Same way with Elizabeth Taylor. Say if you were reviewing one of her movies, or you in a digital library had photos of Elizabeth Taylor, that you would use Elizabeth Taylor and not Elizabeth Burton, for example. Another thing that controlled vocabularies or authorities can do is they can show a hierarchy of terms. Library of Congress subject headings does this. It'll often show you, what's the broader term. Say there was Albany, New York, the city. It might have Albany County first and then Albany, New York, the city. It might have above Albany County, for example, New York State. You get the idea. Here's an example here, and this is something that sort of the more high quality the authority is, or the more detailed it is, this is where you get hierarchies of terms. This was one I got out of the metadata book by Miller, and you'll see this out in other readings and stuff, but basically it's a spectrum, or they use the term typology, but I like spectrum because typology sounds like we're talking about something else, but it basically shows the spectrum of control in a controlled vocabulary. So you might have a list which only handles for certain aspects of that authority list, synonyms, and ambiguity control, that's hard to say, hierarchical relationships, we just talked about that one in the previous slide, and then you get up to here where it starts showing association relationships. These are the sort of things that we're going to talk about in linked data, but basically the further to the right you get, the more control there is, the more expensive it is to maintain that thesaurus or thesauri if you have many that you're maintaining, but the better it is. So there's trade-offs and benefits to using one that's less authorized, if you will, and one that's increasingly more authorized. Again, another sort of aspect is it handles for ambiguity or disambiguation. If you have a bank, what kind of bank are you talking about? A mound of dirt, like a bank on the side of a hill, a container, or a financial institution. Again, these are things that both humans need to know, but a computer would also need to know to be able to basically facilitate searching of your digital library. Okay, so up until I would say I don't know, maybe 5 years ago, or excuse me, more like maybe 2 to 3 years ago, when I would talk about work that I do, digital libraries and XML, and marking up digital documents so they can be read on the web. What I saw in terms of using metadata to facilitate all that was a decline in the importance of subject headings and sort of conventional cataloging. This is me speaking. I may be in a minority and completely crazy, but I really think it's a true observation that the use of subject headings were getting harder and harder, I don't know how to put it, more expensive to use in metadata. And part of it, the expense was hard to justify when you have the rise of search and Google. You think about yourself, like when's the last time you've gone in Minerva, University Libraries, OPAC, and done a subject heading search? It's just something we don't do like we used to, say, pre-World Wide Web or pre-Google. So let's just talk about what the rise of search and how it's become really dominant and how we sort of think of searching for digital materials. Google, you all know this, was founded by Larry Page and Sergey Brin, both Stanford graduates. What they did was create a bunch of server farms and have all those server farms basically searching the web, running crawls on it. And they have these algorithms, and that's really what they were the ones who came up with. The algorithm was really their secret recipe, if you will. They put a trademark on it. It was proprietary. More or less, it was a secret, I would say, for about the first 5 to 6 years of Google, and now most of the people know it. I mean, if you talk to computer scientists here at UAlbany, they could probably tell you what the algorithm is or point to it. It's not like they wouldn't say it to you, but they would say this is more or less what they're doing to search the web. And Google, it's a pretty expensive enterprise that they run. I mean, search is really how they make a lot of their money until they bought YouTube and these other services they do. But search was really what their bread and butter. And so they have hundreds of thousands of servers around the world. It uses a lot of electricity. One of their big issues is how do you run these server farms efficiently and keep them cool. They generate a lot of heat. So that's a whole other conversation about. It's very interesting. But so search, what Brin and Page sort of went on was that the web is very unstructured. You're thinking about people putting up websites of their cats, anything from that to the Library of Congress putting up their digital library materials. And so what Brin and Page were trying to do was to take the web, which was very messy, and create order out of it, and using these indexes. And so their server farms would, their algorithms would search or crawl the web and create these things that are called page ranks. There were indexes that basically assign value and describe the web in a certain way that when you're searching the web, you have to put web in quotes because you're not really searching the web. What you're searching is Google's indexes. And then those indexes are very optimized in a certain way to try to give you, to try to answer your search inquiries as smartly as possible and give those results back to you. So search, until I would say the past year or two, maybe 3 to 5 years, depends on who you're talking to me was really dominated by this paradigm. When you think search, you think Google. And when you think access, you think Google. When people think about optimizing their digital library, we want a Google-like interface. When we think about optimizing our library website, or in my case, the archives website, the paradigm again was the Google search box. Keep it simple, stupid. All these sort of ideas that Google really perfected was to not make the user have to think very much. So I say all that. So after saying all that, to me, I saw the expense of adding subject headings. Again, when you take 603 or 602, especially 603, there's a lot of work that catalogers do to assign subject headings to a book. Now, a lot of that's done in advance. If you buy a book, a brand new book, it comes out, the record's already created for you, so there's only really 1 or 2 catalogers that do that, and then they sell the MARC record to various libraries, so on and so forth. But if you're doing, say, archival material or material that maybe there is no MARC record that exists for it, then the cataloger or someone's going to have to do that work, the metadata specialists, so on and so forth. So in digital libraries, and when I do work with my XML class, I have students, and you all are going to do this, assign subject headings, but I would often put in a little bit of I guess, a footnote and say, I don't know how much longer the future of subject headings, what the future of doing that kind of cataloging has for digital libraries and the web in general. Now, I have to say, I've done a 180-degree turn when I've realized what the role that linked data or the semantic web is going to play, not only in digital libraries, but everything. Everything is going to be affected by linked data. It already starting to, but that's the future of the web. And so let's learn about it. If you haven't heard about it before, or heard about it but you still don't know what it means, let's talk about it for a little bit. Tim Berners-Lee, basically he's the one that coined the phrase, both linked data and semantic web. Semantic web came first, and then linked data is sort of a more specific sort of how are we going to do the semantic web. That's what linked data sort of came out of semantic web. But if we remember, Tim Berners-Lee is the inventor of the World Wide Web, so he came up with the protocol on how to do HTML and the client client-server sort of relationship. He came up with all the sort of theoretical, technical details of how we're going to make this work, and then Al Gore did the rest. No, I'm just joking. We've talked about Al Gore before. Al Gore did do a lot. He basically did the legislation for making the World Wide Web happen, but really it's Tim Berners-Lee. If we want to say there's one quote-unquote inventor of the web, it's Tim Berners-Lee, but he did it with the help of many others. So semantic web or linked data it uses a standard called Resource Description Framework, or RDF. That was the original one that was being called to use, I would say, up until a few years ago. We have another one we're going to talk about in a couple slides. So ask the question, so if we're already using XML, again, this is for you all who have taken my class or know something about XML, isn't the web already understandable by computers? That's kind of some of the stuff we talk about in the XML class when we talk about using XML over HTML. So we're going to talk about that a little bit in another slide. But basically the semantic web was laid out in a famous article in Scientific American in 2001 by Tim Berners-Lee, but also Jim Hendler and Ora Lassila. I don't know, or Lassila. I don't know Ora Lassila, but Jim Hendler is actually a professor up at RPI. I've been trying to get him to come here to speak at UAlbany. He's spoken here at least once before. Brilliant man. You can see videos on YouTube of him if you're interested. But basically in our backyard we have one of the originators of the linked data movement. Really fascinating guy, and Tim Berners-Lee is, for that matter. Okay, so we have XML. Why do we need linked data? Well, XML did mark up web information and structure in a way that HTML did not do. Computers could, and I put quote, could read XML documents, and you could do things like restructure the data, manipulate it, update it, delete, send it over the web safely. You could do all those things that you could do with a database, but it was very web friendly, whereas a database is not as web friendly as XML. It allowed computers to quote unquote talk to each other via serialization, which means that basically it could use ASCII code to talk to each other in a kind of international accepted format. Before the rise of XML, most documents were binary, which meant that the document needed to be opened up by specific programs. So for example, if I had a Word document and I was sending it to you, I couldn't just send it over the web in the same way I could send XML. I would need to send you the document, and then you would need to have MS Word to open it. If you had WordPerfect, same way. So communication among the web was very difficult before XML. And even with databases, they communicate with each other, but you always had to do that on a server, because interacting with a database via the client, there always has to be some translation there because of security reasons and just basically how databases work over the web. Database is really a technology that came about pre-World Wide Web, and I guess to a certain degree really pre-internet. So XML was like the first sort of data container standard, if you will, that was optimized for the web. Okay, XML was good, but the one thing that XML did not do was really help computers understand what was in these XML documents or what was in these HTML documents for that matter. So the web is linked together. That's easy. We've been doing that. That's really the fundamental part of how the web works. Lots of relationships. It's great for humans. We can link to images, charts, and other documents. But when we do that, the humans can read it and the humans can understand it and so on and so forth. But computers don't understand those relationships like humans do. And I'm glossing over a whole lot of technology, but I'm making some assumptions that we all kind of more or less know how the web works, at least on a cursory level, because we've all clicked on the hyperlinks and we've navigated through the web. So it works very easily for humans. We can understand these relationships because we're humans. We have a brain. We can understand those. There's a lot of inferences that humans make that we take for granted that computers cannot do. Computers are dumb, and they need to have these relationships explained to them. So that's what linked data does. It explicitly expresses things in relationships like names, birthdays, places, what those relationships are. Is it a friend? Is it a parent? Is it a child? Husband, wife, teacher, student. Oh, I mean, there's just hundreds, thousands of relationships that you could enumerate there. It links to a name like Frank in a website to another person like Jan or another website, etc. So Frank is would be like a person, for example, or name, and then knows Jan. So that's the relationship, and then she is the parent of Tim. So that's another relationship. We express in a common format, so the technology standard that we use right now, there may be more coming down the road. The first one was RDF, which I just mentioned, Resource Description Framework. That's been updated with RDF with attributes or JSON linked data, and we're going to talk about both those in another slide. So we do it using authorities. We've talked about authorities, why they're so important, URIs and triples. So let me just back up and again underscore why conventional or traditional cataloging techniques are now so important, because all of linked data relies on authorities to do its work. And I'll repeat that again. Linked data has to have for it to operate right, we can't have many different versions of one word that we're using in linked data. We need to have authorities to dictate that. And computers will reference those authorities and then know when you're talking about Albany County, it uses a URI, we're going to talk about that in a minute, to basically consult that authority, find out what Albany County, for example, you're talking about, figure that out, and then actually make that relationship between things. Resource Description Framework in Attributes RDFA is an XML-based standard. It's a W3C recommendation, so it's a standard with a huge body behind it. It allows you can use it as XML alone, or you can mix it up and use it with XML and HTML. And again, XML is a serialization. That just means that it's an ASCII text and allows you to communicate and actually give using RDF meaning to the documents that you're marking up. JSON, on the other hand, JSON's sort of a young upstart. It's a competitor to XML. If you're to take my XML class this summer, I'm hoping to incorporate more JSON into it. JSON can't do everything, but it does a lot of things that XML is a little sort of, relatively speaking, kind of clumsy at doing. But basically, JSON is a JavaScript object notation. It's very minimal, very concise and terse. There's not a lot of angled brackets in it, for example. XML is very verbose. There's a lot of typing involved with XML because it's very explicit. JSON is explicit, but it's very to the point, if you will. Like, there's just a lot less syntax that you have to use to do JSON, whereas XML, there's a lot of syntax that you have to use, a lot of keystrokes, keyboard punching that you have to do it. JSON's much leaner and meaner, if you will. And this JSON linked data or JSON LD is basically a standard for using JSON to mark up information on the web using linked data. I'm not going to get into too much of the details. Again, we're not going to really do linked data in the course. I just want to make you aware of it. But the sort of scheme that it uses, or the paradigm, if you will, it does everything in triples. So there's a subject, and we talked about Frank knowing Jan. So Frank would be a subject. Frank would be somehow referencing a URI somewhere, an authority. The computer would be able to console that and know what Frank it is. It could be Frank Zappa, for example, the famous musician. So it would, via URI, it would reference Frank Zappa and get that authority. That authorized version of Frank Zappa might have his birth date on it, might say that he's a musician, so we know which Frank Zappa we're referring to. There's very few Frank Zappas in the world, but there could be more than one. And then it's going to show that relationship. So it could be the predicate could be member of his band, or bass player, son of, parent of. It could be all sorts of relationships we could think of. Whatever that relationship is, it's also going to consult a URI, and that would be the computer, to figure out what that link is and what the meaning of that linked data is. Consult that, and then figure that out via URI technology. And then whatever that relationship is, say Frank Zappa to, let's say Terry Bozzio. We won't use Jan, we'll use Terry Bozzio. I think that was the drummer of Frank Zappa's band. They would say what that relationship is, drummer of, member of, bandmate, I don't know. It could be some kind of relationship, but whatever relationship you're going to use, it's going to be an authorized one. You're going to consult an authority to make that relationship, and then Terry Bozzio again is going to go to some kind of authority via URI technology. That's a universal resource. It's basically like a URL identifier, universal resource identifier. Via that technology, and find out who Terry Bozzio is. So again, birth date, if he's alive or dead, drummer, that sort of thing. So you can disambiguate from any other Terry Bozzio that's alive in the world. Again, same way with Frank Zappa, you want to disambiguate that name from other names so that the computer, when it's doing its linked data thing, can understand what that explicit relationship is, and then do its magic that computers can do, which is to answer questions for humans. So again, I kind of botched up the example, but we'll go back to the original one. Frank knows Jan, subject, predicate, object. That's a triple. So I have just a little bit more here. I thought what I would do is, again, just kind of wrap up what linked data is and where we are. Linked data is really in its infancy. It really is in its infancy. It is no longer pie in the sky. People are doing it. I'm going to show you an example. Google is doing it with their knowledge graph. But really, this is the future of digital libraries. We just won a grant from the CLEAR, Council on Libraries and Information Resources. It's one of their hidden collections grant, and basically what we're doing is digitizing all these print records that we have in the archive, and we're going to put them out on the web, and we're going to do this using linked data. And right now, using it is going to be maybe minimal, but we're going to be set up for down the road when linked data really does become much bigger than it is. We don't have to go back and redo all that work. So when we're basically doing metadata work on all these digitized index cards that we're doing, I'm not going to explain the whole project, but the metadata specialist is going to be using linked data. We're going to choose an authority like SCOS or Library of Congress subject headings or Dublin Core, pick an authority and maybe multiple authorities, and we're going to assign this to this digital project we're using. So let's look at, I'm going to close out of this. Let's get on Google, and I want to show you some of the knowledge graph stuff. You may be already using it and not even know it. close that out and pull over Google. So one of the things that I talk about in my XML class is when we talk about like autocomplete, things like that, that's something that is sort of been with us for a while and is not linked data. It really is a different technology, although they may be using linked data to facilitate it, but the main sort of function of, like, for example, autocomplete is really kind of a result of the Web 2.0. So this would be a autocomplete or auto recommender kind of thing. So if I'm looking up a hockey team, so I look up Washington. So I've already typed in Washington. It's doing an auto suggest here of post. But if I keep going and type in cap, all right, I get county. So Washington County's here in New York. You know, I might just go with that, but I might not. I'm looking up Washington Capitals. Okay, so already we've got basically everything's Washington Capitals. So if I click on that, I'm going to get results that have references to Washington Capitals. So that's something that's been with us for a while. That's not linked data or a good example of linked data, although Google, who knows what all they're doing. I mean, they may be using linked data to somehow facilitate that search. This is an example, and I'm just searching I'm using Google Chrome, and I'm searching right in the actual URL where you would type that. You can just do searches right in there. You don't need to use the search box. You know, if I want to look up, I can just do a Google search from there. But here's something that Google is doing, and they're using linked data to do this, and this is that knowledge graph thing. This is something that's not a search. You're actually getting answers, like specific answers, not just resources, an actual answer to your question. So let me look up let's see, what? Oh, you can already see I already did this one. Let's do this one. What year was George Washington born? And this is the knowledge graph. This is not a resource. This is an actual answer to my question. Now, there are other references here. I don't know, you know, Abraham Lincoln's pretty popular, President Obama, so on and so forth. But this is a knowledge graph. This is linked data that's basically doing things that computers could not do for us before the advent of linked data. Let's see. Boy, what is... Oh, let's look up a disease. What is... Alright, let's see if it gives us an answer. Might not. Okay, so that one wasn't as easy. That's... I mean, it did give us over here. I guess it did. It gave us our Wikipedia. So it did give us an answer. What about a where is? And I'm going to make this my last one. Where is Geneva, New York? Yeah, so it gave me a map here. So again, this is linked data. You can see why this would be pretty neat. I guess it's sort of Siri taken to a whole new level. You know, Siri in your iPhone, or I don't know if she's in iPhone or if she's in a Google, you know, you can tell how stupid I am when it comes to smartphones. But anyways, it's taking Siri to a whole new level, and this is what I really see the future of digital libraries moving toward. It's going to be any project you're going to be involved in. If it's anything at scale, someone's going to, you know, at some point ask the question, you know, how are we going to make this linked data compliant? What authority are you using? So long live controlled vocabularies. I at one point really felt like, where's the value in that? And now with the rise of linked data, I can see that it's now more important than ever, and the sort of traditional roles of cataloging and metadata work are going to be as important, if not more important now, than they ever were in the past.